Okay, so this is the diagnostic test for the book I've written, Digital SAT Math, or Overcoming Digital SAT Math. You should be timing yourself, if you have this already, for 42 minutes to complete the entire diagnostic test. And then after, make sure that you go to the Analyze Your Diagnostic section, which is like the page after the scratch paper at the end of this, to see which chapters you should be doing. And I'll go over that towards the end of the video after we've completed all these problems. But for now, if you have this resource, I recommend that you pause, do all of the questions by yourself, and then skip to when I am analyzing the diagnostic and showing you how to like score it to know what chapters to do. So let's get started with number 1 right here. Remember, you can use the calculator the entire time, just so you know. For number 1, it says if x is greater than 6, then this is equivalent to. So we're trying to find an equivalent expression. Now, you'll notice that it has a bunch of fraction bars involved, and one way that we can get rid of this is by multiplying the top and the bottom by a certain number that'll get rid of those pesky denominators for us. So let's think, what number can do that? Well, if we multiply by 36 over 36, because that's just the same thing as 1, it simplifies to 1. If we multiply by 1, we're not changing the value of the expression. If we just multiply by 36 over 36, when we multiply by 36 on the bottom, it's going to cancel out these pesky denominators, because 36 times x minus 6 over 36 cancels out that 36. And then when you multiply the 36 times this portion right here, well, 12 goes into 36 3 times, so this is going to cancel out to 1, and this becomes a 3 times all of this. So let's now distribute that 3 to each term right here, to the x and to the 9. So we've now distributed that 3 to the x and to the 9, and then I've just copied over the x minus 6, since that's just x minus 6 over 1 is just simplifying to x minus 6. And now I'm going to multiply the top 36 times 6 up here. And I get 216. Now I'm going to combine like terms on the bottom. So I'm going to put my x's together and my regular numbers together. And when I do that, I get that the answer is B. Okay, for number 2, what you need to remember is that whatever's being multiplied by something on the left-hand side equals this what it's being multiplied by on the right-hand side. It's kind of easier to see visually, but an example would be like whatever the x squared, I can't speak today, whatever the x squared term ends up being on the left-hand side, whatever's being multiplied by that has to equal what's being multiplied by like the x squared term on the right-hand side, and that applies to like x cubed, x to the 4th, like whatever matches on the left, and on the left has to match what's on the right-hand side of the equation. So what we're going to do is we're going to multiply this all out. Now, when you have a binomial times a trinomial like this, you have to make sure that you're multiplying, for instance, this x times each of the terms right here. And then you do the same thing with the negative 2 right over here times each of these terms. Then we're going to have this all multiplied out, and it's going to look a little more like this portion on the right-hand side. So when I do all of that, on the left-hand side, this is what I get. And then on the right-hand side, nothing's changed. So all I did was copy down what was on the right-hand side of the equal sign. Now, you can pick whichever, like if you want to do x squared, x cubed, like you can pick whichever of those terms is best for you to figure out what k is. For instance, you could pick this x cubed portion, and you could say, okay, whatever is being multiplied by x cubed over here has to equal being multiplied by x cubed on the right. But that's going to be a lot harder than just picking the x squared version, because there only happens to be one term involving x squared right here, instead of it being broken up into 2 separate things like the x cubed is. What you have to do with the x cubed situation is you have to think, how can I rewrite this so that it's just x cubed times something? So if we were to rewrite the x cubed part, it's going to be k minus 2 times x cubed. You can't just pick k or -2, you have to rewrite it so that there's one thing being multiplied by x cubed, and then that has to equal what's being multiplied by x cubed on the right-hand side over here. So that means that k minus 2 would have to equal this 5. So then you would set up that equation, you add 2 on each side, and then it cancels out here and you get k is equal to 7. Now you'll see that was an extra step I had to take, which made it a little bit more annoying to do than if I had just picked the x squared version. So if I pick the x squared version, I just have to think, okay, -2k equals -14. I don't have to worry about rewriting it or anything. And then I just divide by -2 on each side to solve for k, and I get k equals 7. So you could have done either of those options. It's just one is a little bit more efficient. Okay, so now let's move on to number 3. So this is a systems of equations problem, and we're trying to find the value of y. I recommend that you underline, box, circle. Well, if you're taking the ACT exam on paper, do that. On the SAT exam, just make sure that you are paying very close attention to what is in the actual question, rather than like just solving the systems of equations and accidentally putting like what x is instead of what y actually is. That's a very common mistake with these types of problems. So you want to pay really close attention to what the question is actually asking. You could also like make a note on your scratch paper or something like I'm finding y or something as you're doing the calculations, or just like a little note reminder to yourself so that you don't make that mistake on the digital exam. So I rewrote the system off to the side. Now remember, we're trying to solve for y, so I'm gonna try to get rid of my x so that I just have y involved in the system. So you can use elimination, substitution, whatever you want, graphing to solve. I'm gonna just use substitution for this one. So I'm gonna say 2x is the same thing as 16. So that means where I see a 2x, I'm gonna substitute in 16. So instead of -2x, I'm gonna have -16 minus y is equal to -8. Now I'm trying to solve for y and get it by itself, so I have to add 16 each side to move it away from y, or in this case -y, and that's going to equal +8. So then I have to divide by -1, because this is technically saying -1 times y, so I have to do the opposite to move the negative. Divide by -1 on each side, and I get y is equal to -8. So the answer should be A. So for number 4, it says the graph of a line crosses the x-axis at 3. So if it's crossing the x-axis at 3, that means they just gave us a point. They told us that that's the x-intercept where it crosses the x-axis, which means that the x value equals 3. And the y value has to equal 0. So we have a point here. And it also tells us it passes through the point 6, -4. And the y-intercept is k, so technically they give us a third point. Y-intercept, the x is always 0. And then k would be your y value if that's the y-intercept. And then we want to find out, okay, what is the value of k? So let's think, how could we solve this? Remember, it says that it's a graph of a straight line. So lines, we know, follow this sort of equation, a linear equation, y equals mx plus b, where m is the slope and b is the y-intercept. And x and y could be any point, like your x comma y represents like any point on this line. So in order to write a linear equation, I need to follow this, and I need to fill in a number for m, the slope, and I have to fill in a number for b, the y-intercept. So first I'm going to try to find the slope using 2 of my given points. So I'm going to pick this point and this point right here, because there's no like extra variables involved, it's just numbers. So I can easily plug that into the slope formula to find out what the slope is. So as a reminder, this is the slope formula. Remember, with the slope formula, it doesn't matter which of these, like whether it's 0 or -4 that you pick for y2, for instance. It just matters that you're consistent, because these little subscripts, these like little numbers, refer to which point, like which point you're picking from. So like you could call this point 1 and you could call this point 2. You just have to make sure that 3 is your x2 in this formula, and then 0 is going to be your y2, and then that the -4 is going to be your y1 and the 6 is going to be your x1. You just have to be consistent with, like, basically you're starting with the x and y from the same point is an easier way to think about it. But I could have also called this 0.2 and then this 1.1 as long as I'm consistent with the formula and starting with the same x and y from the same point. So I'm going to just call this 0.2 and this 0.1. So then I'm going to do 0 minus -4 over 3 minus 6. Minus and minus is turning into a plus. That's just addition. So then I'm going to have +4 over -3. So that's my slope that I'm going to plug in for m right over here. And when I do that, I have this rewritten equation, but you'll notice I'm still missing that b value. Now, if I were to just plug in what they told me the y-intercept is for b, I would still have a problem because I still have another variable, k. I don't want that. I'm trying to find out what the value of k is. So I could just plug in k for now for b, and then just I have to remember, hey, that's what I'm solving for. I have to do something else to this equation in order to figure out what k is. Well, they luckily gave us these points, meaning that they gave us potential x's and y's that we could plug into the equation and use to solve for k. Now, I'm going to use this point 3, 0 as 3 as my x and 0 as my y. You could use the other point as well. I'm just going for this one because it seems easier. So I'm going to plug in 0 for my y. I'm going to say, okay, -4/3 is my slope times whatever the x value is there, which would be 3, plus k. Now I see, oh, these cancel out, so then I have 0 is equal to -4 plus k, and I just add 4 to each side, and I get k is equal to 4 as my answer. So now let's go to number 5. It says George works in technical support. Each week he receives a number of tickets that need troubleshooting. The number of tickets that he has left at the end of each day can be estimated with the given equation where P is the number of tickets left and D is the number of days he has worked that week. What is the meaning of the value of 200 in this equation? So we're trying to figure out what does the 200 mean here. Now, this is a linear equation. It's just instead of x and y, they're using D as your x value and P is representing your y value, but it's still in that same format of y is equal to mx plus b. Like whatever's being multiplied by the x is your slope, and then whatever is just that constant that's being added onto that is going to be your y-intercept, or your initial value, starting value. It's referred to as a bunch of different things. So you'll notice 200 is not being multiplied by what's supposed to be acting as x here. 200 is that number that's just floating on by itself, that y-intercept, that, or you could refer to it as b if you're thinking of this formula. So the y-intercept is commonly referred to as like the starting value, the initial value, or like a one-time fee. Those are like kind of key words that you can look out for on the digital SAT exam. So those are the keywords I'm going to see if I see any of those in the answer choices. And right away, I see that answer choice B says starts. So let's read this and see if it makes sense in the context. So George starts each week with 200 tickets to fix. So he's working in technical support. It would make sense that he starts the week with 200 tickets and that he is going down by 25 tickets each, what is D representing? Each day that he works. So it is B. So if you don't already have this, pause to read the question. But I'm going to get right into the explanation right now. So this question is basically testing your knowledge of this little formula thing right here. Quantity is equal to the rate times the time. So like whatever the quantity is of something, like in this case, it's going to be canvases, like how many canvases they're painting, is equal to the rate that they're painting the canvases. So like rate is anything that's like per hour, like often we see miles per hour or every or each, that sort of thing. And we see that they use, in this case, the word per. But when you see those words, it's an indication that you have a rate, or in other problems, you might think of it as like slope. They're synonymous. They mean the same thing. So how many canvases they are doing per hour is going to be what the rate is. And then t is our time. So in this case, they use the same exact variable, t for the number of hours. So we need to look at each of these situations to figure out the quantity of canvases that are painted in each situation, and then add them all up to get how many there are altogether. So let's do situation 1 and situation 2. So situation 1 says, okay, the quantity of the canvases is going to be equal to C canvases per hour as the rate times T number of hours. And then situation number 2 says for the following T more hours, he paints C over 2 canvases per hour. So the quantity for 2, and I should have labeled this as like quantity, that was supposed to be 1, quantity 1 and quantity 2. The quantity for 2, the second situation, is going to be the rate, which is C over 2 canvases per hour, times the T more hours. So we have both those quantities. So if we add those together, we get the total number of canvases. So that would be CT plus C over 2T. You could also think of that like as 1 CT plus half CT, which would give you 3 halves CT, or 1.5 CT. They're the same exact thing, it's just written in improper fraction format. Okay, so now let's do number 7. So again, pause read if you want, but we're finding this value basically, or one possible value of that. So you're not just finding X, you have to figure out, okay, what are my possible X's, and then pick one of those to plug in here to find one of the possible values for this expression. So I'm going to actually separate this inequality into 2 separate parts, like this. And now I'm going to basically solve each of these inequalities to figure out my possible X values. So let's start with the one on the left. So I have to get X by itself, just like I do with equations. It's basically, inequalities are the same thing as equations, except there's one extra rule where if you divide or multiply by a negative value, you have to flip the sign in the other direction. Like this symbol, the alligator mouth is how a lot of kids refer to it, flips around if you divide or multiply by a negative value, but everything else is the same thing as if we had just an equal sign there. So we're going to try to get X by itself by subtracting 5 from each side first. And notice this is a fraction, negative 16 over 3, so I have to turn this into a fraction before I can start subtracting these. So negative 5 is the same thing as negative 5 over 1. So to make it be something over 3, I need to multiply the bottom by 3 to get to 3, and whatever I do to the bottom, I have to do to the top. So then I get, this is actually negative 15 over 3. So now I can easily subtract those, and this is what I get. Now remember, I have to get X completely by itself, so I have to do the opposite of multiplying by negative 3, which is dividing by negative 3 on each side. And remember, when you multiply or divide by a negative, this inequality symbol is going to have to flip. So this is going to have to turn around like this, and then I'm going to divide each side by negative 3. So I'm rewriting my calculations over here. Remember, when we're dividing with fractions involved, we have to make sure they're both in fraction format, which is why I made this instead of just negative 3 over 1, because it's the same thing. And then we have to keep change flip. So I'm going to keep negative 31 over 3. Oops, that's a bad 3. That's supposed to be a 3. And then I have to change the division to multiplication. Then I have to flip this negative 3 over 1 to be negative 1 over 3. And then I'm going to multiply these together. And when I do that, I get 31 over 9 is greater than X. So now I'm going to do the same thing, basically where I isolate X for this other inequality right here. So I'm going to start by subtracting 5 from each side. And remember, in order to do these calculations, I have to make sure that they have the same denominator. So this cancels out, and then I have to make this into something that is over 2. So then to do that, I have to multiply by 2 on bottom, and I have to do the same thing to the top. So this is saying I'm subtracting 10 over 2. So now I'm going to have negative 3x is less than negative 3 halves. And then I have to get x by itself by dividing by -3. And again, if I divide or multiply by a negative value, I have to flip the inequality symbol. And then remember, I have to keep change flips, so I'm going to do -3/2 times -1/3. And then I could cross cancel. You could also just multiply and then simplify if you want, but this is faster. So 3 and 3 cross cancel to 1. And then we have -1/2 times -1/1. Negative times a negative is a positive, so we're going to have x is greater than +1/2. So this is on your test where it would be helpful to use a calculator. I mean, you could do it on your own if you want, but I mean, there's no point. You get the calculator the whole time. So I'm saying that x has to be less than 31/9 and it has to be greater than 1/2. So I'm going to actually erase so I have more room and rewrite this. So this is what it should look like when I rewrite it. And I like to think of these in terms of decimals. So what I was saying about the calculator is, I mean, if you don't already know this is 0.5, you could do 1 divided by 2 because the fraction bar is just a division sign, same thing. So x has to be between 0.5, and if you do 31 divided by 9, it's 3.4 repeating forever and ever. Now remember, they said x is an integer, so that means that x has to be, basically integers are like your whole numbers, your regular numbers that you're counting, like 1, 2, 3, 4, like all of those, and their opposites. So if I'm thinking x has to be between those, but it also has to be an integer, my possible values for x can only be 1, 2, and 3. Now remember, I'm solving for -2x plus 5. So if I want to do -2x plus 5, for x equaling 1, that would be -2 times 1 plus 5, which would be -2 plus 5, which gives me +3. If I wanted to pick 2, which is completely fine because it's only asking one possible value, not a specific value of this. If I want to pick x equaling 2, same thing, -2x plus 5, but instead of 1, I'm going to plug in 2 for x. So then it's going to be -4 plus 5 is equal to +1. And then I'm going to do the same thing for the last possible thing that x could be, the last possible value of x, which is 3. And I'm going to say -2 times 3 for my x value is going to, plus 5 is going to equal -6 plus 5, which equals -1. So these are your possible answer choices. What you would do is just pick one of those. Like, you're not going to write every single one of those as the answer. It just asks you pick one of the possible answers. So if you plugged in any of these, you would be marked correct. Okay, for number 8, it says, well, you can pause and read, but basically we're finding out which of these could define the function that's being graphed up here, like which of these matches the function. And we know m, n, and k are positive constants. So this is requiring you to remember a specific formula that refers to quadratics, which is, and parabolas, whichever term you want to use, which is what we have here. And this is the formula. We usually just write a y instead of g of x, but they told us y is the same thing as g of x in this case, so y is equal to all of that, or g of x is equal to all of that, where h and k are going to be your vertex in the context of this formula right here. So we have to say, okay, we're referring to this formula, and we want to know, well, what are my possible vertex, or what's my possible vertex for each of these formulas, is how you would say it, using this, or each of these equations using this formula. But you'll notice that all of these answer choices don't look exactly like what we have right here, because they have the -k portion on the left-hand side of the equal sign. To fix that, we just need to move it over to the right by adding k to each side to move it. And now you'll see it looks a lot more similar to what we have right over here for our vertex form for parabolas. Now, one characteristic that you need to know about parabolas is whatever is representing the a value out here, if a is positive, then that means that the parabola is going to go like this. It faces up. So that's if A is positive. If A is negative, then it faces downwards like we have here. So we need to make sure that whatever is outside of these parentheses being multiplied is supposed to be a negative value, because that means that it would be concave down, just like we have here. Now remember, m is positive, so that means if we have a negative m, we have a negative value, which is what we want. So automatically I can cross out B and C from that. Now I'm going to use the vertex form to figure out, hey, what point is my vertex for each of these equations? I like to remember that the vertex is always, if it's in vertex form, the opposite of what's next to the x inside parentheses. So like if you have minus n, the opposite would be positive n. And then whatever the y value is, or the k value, whatever you want to refer to it as, for the point that's the vertex, is just the regular whatever's floating out here, whatever's being added on the outside. So that would just be regular old k. So this is saying for A, it's saying the vertex is n comma k. And then if we did the same thing for D, well, the opposite of n is going to be negative n. And then we just have regular k out here. So n is also a positive value, k is a positive value. So this is saying we have a positive and a positive. If we have a negative of a positive number, that's just negative, and then k is just positive. So we have to say, okay, when we look at the graph, is our x and y positive positive, or is our x negative and our y positive? Well, you'll see it's in the first quadrant right over here. So we have positive, positive, because it's going to be a positive, that's a 4, and then a positive 7 right here for the y value. So 4 comma 7, both of those are positive, so it would be A. So for question number 9, first we need to look at the table and figure out, okay, how can I write an equation for, or a function for this, so that I can plug 8 in for my x value of the function. A lot of people would mess up and say that, oh, I'm going to look where there's an 8 in the table, but remember, this is in the f of x column, so this is saying f of x is equal to 8, not that you're finding f of 8. This means I'm finding the function when x is equal to 8. We don't see when x is equal to 8. Like the value of the function when x is equal to 8, which we don't have. So we need to form an equation or a function that we can plug 8 in for x to solve for what f of 8 is. So I'm going to look at the table and I'm going to see, okay, how is this changing? Well, I see from this to this, it's going from -6 to 1. That means it's going up by 7. And then from -3 to +2, it's going up by 5. Let's see if it goes the same over here. So from 1 to 8, it's going up by 7. And from 2 to 5, it's going up by 5. So it's changing the same amount for the y's, or the f of x is another way to think of it in this case, and for the x value. So f of x is changing and x is changing the same amount each time. So we know that the change in y over the change in x is referred to as the slope. And remember, y you can think of is the same thing as f of x. So we could also say the change in f of x over the change in x represents our slope for a linear function. Now, a linear function, it's basically y equals mx plus b, but instead of y, you write f of x. So the same thing we were doing earlier with y equals mx plus b, but instead of y, we write f of x. So we can figure out the slope from this because it's just the change in f of x, which we saw was 7. It goes up by 7. And then over the change in x, which is just going up by 5. So it's just +7 over +5, which is just 7/5. So that's our slope. So we can plug in 7/5 x and then put x plus b equals whatever f of x is. Now we need to also find out what value we can plug in for b to have an equation that's actually usable for the situation. So, or useful, I should say. I can't speak today, sorry. So then what we're going to do is we're going to say, okay, what is a point that we could plug in so that we could plug in a value for x and a value for f of x. That way the only unknown in this scenario would be b. And then we could easily solve for b. I'm going to just pick 2, 1. Now, remember how we always write points x, y? It's the same thing as an xy table where we see an x, y point. It's just instead of y, we're thinking f of x. So this is my x, 2, and my f of x is 1. You could have picked one of the other points as well. Like you could have done -3 for x and -6 for f of x, or you could have done 7 for x and 8 for f of x. Doesn't matter as long as you're making sure that they're on the same row, or sometimes they'll do it to the same side. They'll do it like, how do you say it, like this, where it'll be like x and f of x, and then like it would be written like 2 and 1 are the matching ones on the top and the bottom. You just have to make sure that like the row matches or the column matches if it's written like this, to know that that's a point. That's an x and an f of x that go together. So I'm going to plug in 2 for my x and 1 for my f of x. And then you'll see I just have one unknown, b, which I can just easily solve for. So I'm going to say 1 is equal to, 2 is the same thing as 2 over 1. So if I multiply those, it's going to be 14 over 5. And then I just have plus b that I copy over. So to get b by itself, I have to subtract 14 over 5 from each side of the equation. It cancels out here. And then I get b is equal to 1 turns into 5 over 5 so that we have a common denominator. 5 over 5 minus 14 over 5. So I'm going to keep that common denominator of 5, and I'm going to do 5 minus 14 is going to be -9. So now I'm going to plug that in for b right here, and I have a full linear function that I can use now. So it's going to be f of x is equal to 7/5 x plus -9/5. You could also just say plus a negative is just minusing 9/5, whichever one you want, doesn't matter. They being the same thing. So now what I can do is I can solve for f of 8 by plugging in an 8. Ooh, that was supposed to be an 8. An 8 everywhere that I see an x, and then I'll figure out what f of 8 is. So I rewrote it like that, and then now I'm going to say, okay, f of 8 equals, I'm going to multiply these, so this is the same thing as 8 over 1, so 7 times 8 is 56, 5 times 1 is 5, and then plus a minus is just minus, so minus 9/5. So f of 8 is equal to 56/5 minus 9/5, so I just have to keep the common denominator because they both have a 5, so that's already done for me. And then I have to do 56 minus 9 to get my numerator. And when I do that, I get 47/5, or you could write that as a decimal and it would be 9.4. Okay, so let's do number 10. Sarah and Dave have 80 books combined, or you can pause and read. I'm going to go ahead and start writing this out. I don't know why I keep doing that. Okay, so let's do like a little chart for the scenario. So we have Sarah and we have Dave. So Dave lets Sarah borrow 3 of his books for every book that Sarah lends to Dave. So let's think of how their number of books, the number of books is changing for each of them. So every time that they go through this whole borrowing process, Sarah's gaining a net of 2 books and Dave is losing 2 books. So Sarah also starts out with 30 books. She has those 30 books. If Sarah and Dave both have 80 books combined, that means that Dave has 50 books at the beginning of this process. We want to know after how many times that they're trading, do they have an equal number of books? So let's write this out as an equation. So let's start with Sarah. So Sarah has an initial value of 30 books, and then it's going to go up by 2 books for every X trade that they do. So every time they do a trade, which the number of trades is represented by X, she's gaining 2 books. And then we want to know when is that equal, that's going to be the number of books for Sarah, and when is that equal to the number of books Dave has? Well, Dave is going to start out with an initial of 50, and it's going down by 2 books for every X trade. Now, if we want to know how many trades, that means we're solving for x. So that's what we're going to do. I'm going to add 2x to each side, so it cancels out here, and then I'm going to have 30 plus 4x is equal to 50. Then I'm going to subtract 30 from each side, and that's going to give me 4x is equal to 20. And then I'm going to say, okay, I'm going to divide by 4 to get x completely by itself. 20 divided by 4 is 5, so it would be after 5 trades. Okay, so pause to read if you haven't already done this problem. Now we're trying to find the range for the combined data set of these two cities. So if we combine the data sets, then let's think what is going to be the overall max and the overall min, because range would be max minus min. So if we combine these, the absolute maximum value would be 85. That's the highest it can go. And the lowest, the minimum, would be 60. So you would have 85 minus 60, that equals 25. So which of these could be the range? So the only one that matches 25 would be C, greater than 20 degrees. So pause to read number 12 before I get into the explanation. So for number 12, we have that the mean is greater than the median, and I think it's easier to visualize this with a box plot, so that's why I drew that. Oops. So the mean is greater than the median would look like this, where it's going to be positively skewed. So the answer to this one is going to be B, and the reason behind that is because if you have where the box plot is positively skewed or where the mean is greater than the median, that basically means that you have some higher values over here that are skewing it so that the mean, or skewing it towards this side of the number line, I guess is how you could call it. I'm trying to think of the best way to say that. So basically there's some higher values over here that are pulling the mean higher or towards larger values, which is essentially what B says, just in the context that we're given with this particular survey. There are a few people who spend much more time watching TV than the rest. So there's a few of these larger values over here that are helping to skew the mean, or skew the box plot. Sorry, it's hard to keep up with using the right terms. But basically there's some higher values over here that are pulling the mean towards those higher values. Like those, some of the few higher values, there are a few people who are spending much more time watching TV over here that are pulling the mean higher. Hopefully that clarified things. It's hard to think of my wording at the same time. Sorry, guys. Okay, again, pause to read number 13 if you haven't already. So based on the given data, we're trying to find the most appropriate conclusion. So they said that there's an estimated 5% margin of error. So margin of error, you can it's easiest to think of as how off they're expected to be. So how much room there is expected to be for error. So a 5% margin of error in this case would mean, okay, we estimated that 30% of the people, the population, attended a cultural event at least once per month. And if the margin of error is 5%, they're saying, okay, but it's estimated to be 30%, but we're leaving this 5% room of error. So it could technically be 5% less or 5% more. So 25% to 35% is what they're expecting for, the number of people that attend a cultural event at least once per month. So automatically I'm looking for that 25-35%. I see that that's with C and D. So now I'm determining whether C is the better answer or D is the better answer. So C says the sociologist is between 25% and 35% sure that most people attend a cultural event at least once per month. Now, that's not what margin of error is. Margin of error isn't saying how sure you are of something. It's saying this is how much is plausible that my estimation could be off by. It's plausible that my estimate is going to be off by 5%, not that I'm that percent sure. It's not saying that. It has to do with the actual estimate value. So it would be D. It is plausible that the percentage of people who attend a cultural event at least once per month is between 25 and 35%. So that's the correct answer. Okay, so let's try number 14. Pause to read if you haven't already. So let's start with the original scenario, and then we're going to go to the new adjusted scenario. So for the original scenario, they had a total of 700 comic books. 30% of those are going to be superhero comic books. So if I want to know how many comic books, I'm finding 30% of what the total is. 30% of 700. So if I want to find percent of a number, I turn that percent into a decimal by moving the decimal over by 2. So it's going to be 0.3 or 0.30, whichever you write, it's the same exact thing, times 700 is going to give me the number of superhero comic books. And that turns out to be 210 superhero comic books. So now let's find out how many are science fiction comic books. Well, it says 20%, so if we move the decimal 2 to the right to find 20% of 700, it's going to be 0.2 or 0.20, same thing, times 700 equals the number of science fiction comic books. So then I'm going to have 140 science fiction comic books. So now let's do the adjustments to find the new number of superhero comic books and science fiction comic books. So it says they decide to increase the number of superhero comic books by 20%. So we're doing percent increase by 20%. So that means we have 100% plus 20%, which means we're talking about 120% or 1.2 as a decimal times whatever the original amount of superhero comic books is or was, which is 210. And that would give me my new amount of superhero comic books. And that would be 252. Now it says that the number of science fiction books is going to decrease by 10%. So we have 100% when we have all of the science fiction books. If we decrease by 10%, we're talking about 90% of those science fiction comic books. So 0.90 or 0.9, same thing, times the original amount of science fiction comic books, which is 140. And that gives us 126 science fiction comic books. We want to know how many more superhero comic books there are than science fiction. So how many more means we're subtracting these. And when we do that, we get 126A. Okay, so now let's go to number 15. Pause to read if you haven't already. So we're finding out how the area has changed. So let's talk about the original situation, which we'll just use the regular formula we're used to of area of a rectangle is equal to length times width. Now in the new situation, the new area, which I'll say is A new, the length of the rectangle is divided by 3. So that means my length, because still area is equal to length times width, it's just that my length now is equivalent to L divided by 3. And my new width is going to be triple the original width. So my new width is actually 3W. You'll notice that if you multiply those, the 3's cancel out, and then you have A new is equal to length times width. It's the same exact thing, so area would remain exactly the same. Pause to read number 16 if you haven't already. So this is an example of an inversely proportional relationship. Now, these are less common than the directly proportional ones, but they do sometimes show up, and they can show up on the exam. So the formula you need to remember for inversely proportional is this one, where y and x represent the things that are inversely proportional. So in this case, it would be like the the number of hedgehogs and the number of weeks that of food available. So because think of it, as you have more hedgehogs, like as the hedgehog number increases, you're going to have less weeks available of food. Now, it doesn't matter if you call y the weeks of food and x the hedgehogs or vice versa, as long as you're consistent as you progress throughout the problem. So like if you decide right now, like I'm going to say that x is always going to be the weeks of food, then x, when we continue on, still has to refer to weeks of food, and y has to be the number of hedgehogs. So Alexandra has enough hedgehog food to last her one hedgehog for 4 weeks. So number of hedgehogs, y would be 1. K, and then we have k over the number of weeks it would last is 4. So we can now solve for k by multiplying each side by 4, and we get k is equal to 4. So now we can rewrite this equation to be y is equal to 4 over x, where remember, x is always going to be weeks, and y is always going to be the number of hedgehogs. So if Alexandra offers to feed Zeynep's 3 hedgehogs in addition to her own, we're talking about 4 hedgehogs. So 4 would be y. And then we have 4 on top right there. And then x, remember, is going to be the weeks of food. So then if we want to know the weeks of food, we're going to have to solve for x. So I'm going to multiply each side by x, and that's going to give me 4x is equal to 4. So x is equal to 1. So remember, that's 1 week. Now the question is asking, how long will the food last? But then you look at the answer choices. So it lasts 1 week, but it's all in days. So what's the equivalent of 1 week in days? Well, there's 7 days in a week, so it would be B. You have to be careful with those, like those ones where they kind of try to trip you up with using a different unit. So now let's go to number 17. Now, the easiest way to think about ratios, especially in this context, is those 2 little dots, the ratio dots, are the same thing as a fraction bar. So I like to just replace the dots with a fraction bar. So this is saying like x over y is equal to w over z. And we want to know z in terms of all these other variables. So basically we're solving for what z is. So I'm going to cross multiply, and that's going to give me xz is equal to wy. And remember, I'm trying to isolate z, trying to solve for z, get it by itself. So I have to divide by x to do that. So then I get z is equal to wy over x. So wy over x is A. Pause to read 18 if you haven't already. So we want to find the best estimate of the amount of money the Smiths spend on gas per mile traveled. So I'm going to start out with $3 for every 1 gallon, and I'm going to use stoichiometry, which basically what it is you're just trying to cross-cancel units until you're left with the units you want. So for instance, if I start with $3 per gallon, I want to know the amount of money they spend on gas per mile traveled. So I want money over miles as my unit. So I need to cancel out this gallon. So I'm going to look for another relationship with gallons. Well, 40 miles per gallon. So I'm going to say, okay, 1 gallon on top, 40 miles on the bottom. And that allows me to cancel out gallons and gallons. And then I can just say, oh, that's 3 times 1 divided by 40, which is going to be 0.075, which obviously it's money, which I'll get to in a second. So we have to like change that, and why it says best estimate, not the exact value. So $0.075 per 1 mile, or per mile, however you want to say it. So what's that closest to? Well, that would be closest to 8 cents per mile, B. Okay, so let's go to number 19. Which expression is equivalent to this? So for this, you have to remember that if you're writing equivalent expressions with radicals, one of the rules that you can use is that whatever is inside the radical, like whatever the exponent is, you can turn that into a fractional exponent by saying, okay, y is to the third on the inside. Well, to write it as y to a fraction as your exponent, we would just have to say, okay, what's my exponent on the inside? That's my numerator. Ooh, that's about 3. My numerator would be 3 because there's a 3 on the inside, over, and then the denominator for your fractional exponent would be like the type of radical it is, which in this case, it's like you're cube rooting it. So the little number on the outside would be 3. So it's y to the 3 over 3. And then I'm going to simplify this in a second. And then we're going to do the same thing with z. So z to the 6 over 3. Now, if we simplify those, that's just y to the first power, z to the second power. We don't write like y to the first power. We just say y. So it's just y times z squared, which would be C. So then for number 20, pause and read if you haven't already. So this would be an example of an exponential function. So it's saying that the population is decreasing by 7% every 10 years. So remember, whatever is in the parentheses portion has to be what you're multiplying by over the certain, over every 10 years. So if it's decreasing by 7%, that means that you're left with 93% of the population. So if we're left with 93% and we're multiplying by that, we would have to turn that into a decimal. So the decimal version of 93% would be 0.93. So it has to be either C or D. And then whatever that is being raised to, whatever the rate that we're multiplying by is being raised to, it has to match the time intervals that they're giving us. So they're saying like it's happening every 10 years. So that means that if we plug in, T is in years. So if we plug in, I'm trying to think of the best way to say this. So if we plug in 10 for T, for instance, right here, that would be 10 over 10, which would simplify to 1. So then in a period of 10 years, we're going to be multiplying by this one time because it's raised to the first power, which matches the scenario. Here, if you plugged in T was 10 years, so if you plugged in 10 here for T, you would be raising it to the 100th power, meaning you're multiplying by 0.93 100 different times. It says that you're only taking 93% of whatever you have at that current moment in time. Or if we're talking about like just like the first period of 10 years, like in this example, we're taking 93% or 0.93 of that initial value, 200,000, one time. We're multiplying it by it one time. We're not saying I'm going to multiply by 93% 100 different times or 0.93 100 different times. That doesn't match the scenario that they gave us. They said that we're going to multiply by it or take 93% of that value, or whatever the current value is as we progress, every 10 years, one time every 10 years. So it would have to be D.